We're going to see how to use an electronic stroboscope in order to measure frequency. Now, this is an electronic stroboscope, or just called strobe for short. It's simply a flashing light. It flashes at a regular rate, and that rate is adjustable. Right now it's flashing at 3,600 flashes per minute, and I'm decreasing the rate right now. I can either decrease it or increase it. I can do it in big steps or in small steps. Now, you're probably familiar with strobe lights, for example, a strobe effect in a video clip, or strobe lights that are used at parties. But actually, the strobe light was invented back in the 1930s, and it was used originally to investigate the motion of motors, because the motor was moving too fast to be seen with the naked eye, but with the strobe light, you could make it appear as if it were stopped. I'll show you how that works. We're going to be using for a motor just this fan motor without the blades on it. Instead of the blades, there's this cardboard disc which has a white line painted on it. I want you to think of this as a clock. I'll turn it on. It's a high-speed clock. It's moving too fast for you to see the hand, but when we light it with the stroboscope, you'll be able to see the hand. Let's take a look at that now. So you can see the hand. Actually, you can see several images of the hand. What I want to do is make it appear like there's just one image of the hand and that it's moving as slowly as possible. We'll see why we want to get that effect in a moment. I'm decreasing the frequency now in big steps. I'm down now to 3,200 flashes per minute and now 3,100 flashes per minute. Now, you notice that the line first appeared to be going one way and then stop and go the other way. Let's see why that's happening. First of all, if I could adjust this so that the line seemed to be stopped, it's pretty nearly stopped now. I'll leave it like that for the moment. It's still moving, of course. Okay. If it were completely stopped or appeared to be stopped, then what that would mean would be every time this light flashed once, the line or the disc went around once. So this flashes, you see the line in a particular position. The next time this flashes, the disc has gone around, but the line is in exactly the same position, and that's the only time you see it, so it appears like it stopped. Now, if it appears to be going slowly forward like this, it means that the light is flashing a little bit too slowly. So let's suppose the line starts right here, and between flashes it goes around once and a little bit more, because this light is flashing a little bit too slowly. And the next time it goes around once, back to its original place, and then a little bit more. So it appears to be slowly moving forward if this light is flashing too slowly. Likewise, if this light is flashing too fast, then the line appears to be going backwards. Now, you've probably seen an effect like that in the movies. For example, stagecoach wheels sometimes seem to be going backwards in a video clip. And this is because the video clip itself is like a strobe light. It has 30 frames per second, so it's like 30 flashes of light per second, which are blended together so you don't notice the flashing, but with something like a stagecoach wheel that is moving, you see the stroboscopic effect. Now, I said before that when we have the line appearing to be stopped like this light is flashing once every time the disc goes around once. Actually, there are other possibilities. It's possible the disc could be going around twice for every flash. If we're going around twice, there's once, twice. It would look like it's in the same place every time. It could be going around 3 times or 4 times between flashes. We need a way to determine if it's doing that. Let's suppose that right now it's going around exactly once between flashes. If I then doubled the frequency of the light, then what would happen is that if the line started out here, when the light flashed again, it'd only get around half as far, because the light has only half as much time between flashes. And for the next flash, it would be here and then here. And so we would appear to get 2 lines, 2 images of the hand if we did that. Well, let's try that and see if that actually happens. If it does happen, it means that this frequency is exactly what we said it was to begin with. This is going around once for every flash of the light. I'm hitting a button on here called times 2. So the frequency is twice as much. You can see that 2 lines appeared. So that meant the frequency we started with was the correct one, the one that we wanted. I can hit divide by 2 to get back to where I was. and that frequency is 3,133 flashes per minute. So that's how to use a stroboscope in order to measure frequency. Now it can be used to measure the frequency of many things that move at a regular rate, from rotating objects to vibrating strings. Another practical application is for timing lights for automobiles.